Welcome to the Explainer. Today, we're talking about something absolutely crucial: the professional coding standards that make the difference between software that breaks and software that actually lasts. This is all about creating a shared language for building quality from the ground up.
So let's just start with a question that I swear every single developer has asked themselves at some point. You kick off a new project, right? Everything's clean, it's logical, it's fast. But fast forward 6 months, and suddenly it's this tangled mess where one tiny change over here causes 3 new bugs over there. How on earth does that happen?
Well, this slow decay, it has a name. It's called technical debt, and you should think of it just like financial debt, because the interest on it compounds over time. See, every shortcut, every "I'll fix it later" you do today makes all future work more expensive, more time-consuming, and way, way riskier.
So, how do we fight this? How do we stop the rot? We have to start with a solid foundation. And in the world of software, that literally means starting with the 5 core design principles known by the acronym SOLID. Think of these as the fundamental rules for our smallest building blocks of code.
Each one of these principles tackles a different weakness in how we design our code. You've got principles for making sure a piece of code does one and only one thing, and others for making sure you can add new features without breaking what's already there. Put them all together and you get components that are strong, reusable, and a whole lot easier to maintain.
Now, what's really cool is that these principles aren't just, abstract theories. They prevent very real and sometimes very subtle bugs from ever happening. Let's look at a classic example from one of them, the Liskov Substitution Principle, to see exactly what I mean.
Okay, so here's the deal. In geometry class, a square is a special type of rectangle. That's a fact. But in code, forcing that relationship is a total trap. Imagine you have a function that expects a rectangle so it can change just its width. If you pass in a square, you break everything, because a square's width and height have to be the same. This is a classic violation, and it's why we can't just blindly model the real world in our code.
So having rules for our code is a great start, but building really high-quality software, that takes the right mindset too. So let's move beyond the strict rules of SOLID and talk about a broader philosophy that should guide our decisions. And really, it all comes down to one core idea: simplicity. First up, you've probably heard this one: KISS. And it's a little blunt, sure, but it's a powerful reminder that unnecessary complexity is, itself, a huge cost. The most elegant solution isn't the one that uses a bunch of clever tricks. It's almost always the simplest one that just gets the job done.
Next up is DRY, which stands for Don't Repeat Yourself. Just picture this. You have the same bit of logic copied and pasted in 5 different places in your application. Now you find a bug in it. You have to remember to hunt down and fix all 5 of those copies. If you miss just one, you've just introduced a nasty, subtle bug that could take your team weeks to track down.
And to round out this mindset trio, we have YAGNI. This one fights our natural urge to build features for some hypothetical future. It's basically telling us, hey, focus on solving today's problems, because that feature you think you might need in 6 months, its requirements will probably be totally different by then, and all that work you did up front just becomes waste.
Okay, so let's zoom out. Let's see how this mindset of simplicity scales up into the very architecture of our systems. We're not just talking about a single class anymore. We're talking about how all the big pieces fit together. This is where one key decision can make a system wonderfully flexible or incredibly fragile.
This quote from Joe Armstrong just brilliantly nails the most common architectural trap out there. It's about overusing a technique called inheritance. You just wanted one small piece of functionality, the banana. But to get it, you're forced to drag along this mountain of other code you don't need. That's the gorilla and the entire jungle.
Right, so inheritance creates that super rigid is-a link, just like we saw with the square and rectangle. It's a really tight, permanent bond. The much more modern and frankly better approach is composition. This creates a flexible has-a relationship. You don't become the thing, you simply use the thing. And this example shows the power of that has-a approach perfectly. Instead of creating a permanent flying robot class that's stuck in the air forever, we have a generic robot that has a movement behavior. We can give it wings to fly,
And then, check this out. Without changing a single line of the robot's code, we can instantly swap that out for fins and make it swim. Now that is real flexibility. So, we've got rules for our classes, a philosophy for our mindset, and a strategy for our architecture. But there is one last crucial piece to this puzzle. How do we make sure our code base actually gets better over time instead of just slowly decaying? Well, the answer isn't in code. It's in the team's culture.
And this brings us to a super simple but really profound cultural principle. It's known as the Scout Rule. This isn't about massive, scary refactoring projects. It's about a consistent daily habit.
What it really means is that every single person on the team takes ownership of the code's health. You're in the code to fix a bug, and you see a variable name that makes no sense, or a small bit of repeated code. You just take an extra 30 seconds to clean it up. It's these tiny, constant improvements that actively fight back against technical debt.
So let's just pull this all together. The real key takeaway here is that you have a whole toolkit for building quality software. You use solid principles when you're designing your classes. You apply kiss and dry when you're planning and cleaning up code. You choose composition when you need flexibility, and you practice the Scout Rule every single day.
Ultimately, these principles give you more than just a set of rules. They give a team a shared language to even talk about what quality means. And so the final question this explainer leaves you with isn't just about syntax or algorithms. It's about a commitment to professional craftsmanship. Are you leaving the code better than you found it?